Chapter 24 of SDM4 brings us back to the material we saw in Chapter 2, where we actually have categorical variables, two of them, arranged in a table, and we want to go ahead and either compare goodness of fit or undertake something called the chi-square or Fisher's exact test. So the simplest situation is the goodness of fit test introduced in section 24.1. We have some observed distribution. We want to see if that matches some hypothesized distribution, and we can go ahead and calculate an observed minus expected for that and appropriately normed. So there's, as always, assumptions and conditions for this. The calculations are pretty straightforward. They've involved this form of whatever the observed is for each cell, the expected, the difference between those things squared, that's a positive quantity, divided by the expected, which is also a positive quantity. Add all those up, that actually gives you your chi-square test statistic. There is a table in the back of the book. Your parents would have used that. You, on the other hand, can be using p chi-squared or q chi-squared as a way of figuring those things out. We'll see that in just a minute. Actually, step by step, where you actually proceed through this with a think, show, tell, and the chi-squared calculation. For the most part, we'll let R do that, but it's nice to kind of have some idea. The chi-square distribution has different degrees of freedom in the same way that the t distribution does. This gives a kind of a comparison of what 5 degrees of freedom and 9 does. So goodness fit test, there's a kind of an omnibus alternative for that, and so we want to kind of be thinking about that. Now there are other tests we can be doing when we now have two variables. We want to see whether or not the rows and columns are associated. This has a variety of names and approaches with the same calculation, which can be a little subtle at first. But here we're looking at employment status, by which school someone had gone to. We can go ahead and calculate these to kind of give us a sense of a test of whether or not those two variables, those factor variables, are associated. So we can calculate this. We can go ahead and examine the residuals. The residuals have a particular form. If we take that observed minus expected, now that could be negative or positive, and divided by the square root of the expected value, these standardized residuals kind of have some meaning that we can be using in terms of understanding how things are set up and where we're seeing the deviations from the null model. Chi-squared test of independence, slightly different ways things are structured, same calculations, similar assumptions and conditions. So there's a nice example that takes you through that and examining those residuals again and thinking about in the same way that if we see a difference here, it doesn't mean that there's a causal relationship. We have to go back to our randomization versus observed data. There could be another factor that's confounding things. Just checking, as always, these questions are very helpful. Make sure you're on a good, firm ground, and thinking about places where things can go wrong, and the learning objectives for this. So we've seen a lot of the material we need to be able to go ahead and do everything for this in R. So I'm in Chapter 24 of SDM4 and R. We can load in these data just by creating vectors of the observed and expected counts, and go ahead and kind of look at the chi-square distribution. So here we have xp chi-square, which actually gives us a nice kind of distribution for these. And we can actually go ahead and then calculate that test of homogeneity. Here's a mosaic plot of that as well, which gives us kind of a sense of what's going on. The x chi-square test function will actually give us all the expected counts and the Pearson's residuals, which again can be used to match that in the book. Okay, everything we've done now in Chapter 2, but now thinking about inferential statements posing a null hypothesis of independence.